to this computer. Okay, good morning, everyone. So we are finished with the checking of attendance, and this is our first lecture for MCTE 512, Artificial Intelligence and Machine Learning for Engineers. So today is our first lecture for the first semester school year 2021-2022. Okay, so yesterday we met in the lab and we discussed about the rules of the rules that we need to follow, or guidelines that we need to follow for our class discussion and class lecture and laboratory. So for this semester, everything will be online, including laboratory. So the lab exercises will be given to you as homework exercises, and then you're going to submit your answers through Turnitin. Okay, so today will be officially the start of our lecture. Let me review my screen. Okay, do you see this? Presentation. Okay, so yeah, we discussed today. What I will do is that we will just introduce the basic concepts and some definitions or basic definitions of artificial intelligence and machine learning, and also some applications, and see why and probably answer the question of why machine learning and artificial intelligence is a very popular computational tool nowadays. Okay, hopefully I will be able to answer that after this class. So what are we define machines and intelligence. So normally we say we normally always listen to some people saying intelligent systems and intelligent machines, robots, and computers are intelligence, like this. So what actually defines intelligence? So how do we say that things are intelligent? So we say that things are intelligent when they have the ability to decide on its own. Okay, so especially for machines. Okay, if a machine does not decide on its own, it's not intelligent enough. So for example, what are examples of this where machines will try to decide on its own? Probably those things, those in the control point of view, if something is controlled to move to a certain location and it decides to continue moving to that location because it decides because from its computation, it has not reached that location. So in that sense, that system is able to decide on its own. Any controlled system is intelligent. For example, we say that the air conditioning systems nowadays are intelligent. Why? Because if you set the thermostat, it will keep on working until it reaches the desired temperature that you set. Okay, and then once it is already reached there, then it will try to stop or stop working, or just stop, or just do in an idle mode. So that kind of system is considered to be intelligent. So then, sir, what happens there in the previous air conditioning? There, maybe in the earlier days, air conditionings will just continue, continue working until it's so cold that people will turn it off. Okay, so in that case, it's not intelligent. It is just continue doing things, and then a human person needs to intervene. The keyword is intervention. Some human intervention is needed in order to make the decision for the machine. Okay, so now the next question is, what is machine learning? It is the ability to gather information from data. So the keywords that are needed for machine learning is that data. Data is most important. Without data, we cannot have machine learning. Machine learning builds on data. So it analyzes data. It gathers information. That information is being extracted from the data. Okay, Excuse me. So those are two major keywords that we can consider. Okay, so now let's go to AI, artificial intelligence, and machine learning. So what is artificial intelligence? It is to perform tasks normally requiring human intelligence, like knowledge or knowing and making decisions. Okay, well, these are definitions given in the internet and given by textbooks. So we adapted. We say that artificial intelligence is that system that try to mimic or try to do what human intelligence is capable of doing. Okay, so if a human brain can become creative, then that artificial intelligence machine should be able to create, to become creative as well. It makes decision, yeah, and it knows something. Yes, it's just a database knowledge, you know, you put in there and then you can retrieve the knowledge. That's fine. But decision out of that knowledge, it creates, it tells you that, oh yeah, where is the best restaurant today to eat? Today is like Friday, and alcohol is sorry, yeah, well, it's true. We're all adults here. Alcohol is now not banned anymore because COVID used to ban it. Now it's, you know, so where can we eat at the restaurant with some alcohol at this particular budget? Yeah, and so it will search and give you the information. Okay, so but then again, that's more than what humans can do. So what is different? What is different than, aside from making decisions and having knowledge, that humans can do? I think it is creativity. You know, creativity and intuition. Those things are, you know, when you are intuitive, it's based on certain, you know, sense that you don't even know where it's coming from. Yeah. Okay. So these are some human intelligence that machines that are doing artificial intelligence should be able to do. Okay. And then what is machine learning? It is the ability to gather information from data. So we already mentioned this. And so there are two things, data and information. So now, what is the difference? If we compare the two things, what is the difference? These are just, you know, definitions from textbooks that I put here so that we can analyze how are the two things related and how are they different. Anyone? Okay, the first guy in the class, Mr. Kevin. We cannot hear you.
I don't know what to say.
The first thing that comes to mind.
Sir?
The first thing that comes to your mind, just say it. You're not saying that you're wrong and you're right. Most likely, you know, it's somewhere in between, right and wrong. But yeah, we're not, it's just asking your opinion, that's all.
Artificial intelligence is the use of some devices to act in place of humans, and machine learning is the ability of machines to automatically gather information.
Yes, those are what we mentioned. So what do you think, how are they different and how are they related? So how are they related? Let's just start with their similarities. How are they similar?
I think in machine learning, we use artificial intelligence.
Okay, somehow, yes, that's true. In some cases, people interchangeably refer to machine learning and artificial intelligence. Yes, and we normally, in this class, we will do that. Okay. And but then strictly speaking, some other people would not agree with that. But for now in this class, because this is an introductory course, let's consider them to be, you know, we can use them interchangeably. Okay, but how are they similar? Okay, Mr. Moses.
I think they're similar in terms of using both of them of using knowledge. Machine learning gathers data and then converts it, extracts knowledge or information from it. And artificial intelligence takes its decisions based on that knowledge that it has.
Okay, very good. Yes, that's true that the data and the information they're dealing with at the same time. Yeah, that's correct. What else? Tsepo? How many Tsepos we have? Only one? Okay. Next time, if there are two guys in the camera, please put your names together so that I can call both of you. Okay. Okay. Tsepo. No, we cannot hear you.
Yes, sir.
What are the other similarities? The basic similarity.
I think for both of them, they won't need, once they've been made, they won't need human intervention.
That's correct. Yeah, right. Yeah, that's correct. What else? Kositsile. Okay, Haone. Yes, Haone. I like that. Yes, Haone.
Yes, sir. I think that artificial intelligence needs machine learning for it to make decisions on its own. It needs the information gathered from the vast body of data that machine learning provides.
Okay, yeah, somehow one is the subset of the other. That's what other people are saying as well. Okay, or one is a superset of the other. Okay, so let's yes, I agree, but for now in the class, let's just keep them to be interchangeable. Okay, but yes, they are similar, but as well as they are different. But in the class, we will treat them, when we say artificial intelligence, we also mean machine learning in the class. Okay, what else? What other similarities? Kutsitsile. The basic similarity. I always want the basic ones because the basic ones is the one that where you can really totally, keep things into your heart because you know the basic, just like knowing the person, you know the basic information of the person. When you know the basic information of the person, then it's very close. That person is very close to your heart. What's the basic thing? Basic similarity.
They both make decisions.
They
both make decisions.
Who's that?
Osisi.
Kosisile. Okay. Yeah, they are both making decisions. Both of them are making decisions. What else? They're really basic. Go down to the very bottom.
Machines,
Yeah.
computers.
Who's that? Tsepo.
That.
It is something that makes machines intelligent. Something that material objects that used to be, they're just materials. They're just metals. They're just plastics. But those plastics and metals combined together now is capable of some intelligence. Okay? It gives machines, because usually machines are just machines, like probably gears. Yeah, just gears and pinions and all those are purely machines. Okay, or pulleys, they're basic machines. Yeah, but now these machines, if you combine them together with machine learning or artificial intelligence, it becomes intelligent. It becomes an intelligent machine. Okay, So imagine, you know, you are giving some objects or just a stone, just imagine a stone somewhere lying around, give it some intelligence. That's what it is. And that's the beauty, you know, putting some intelligence into something that is just lying around, not even alive, just some materials or things, rocks, you know, you can say rocks or wood or metals, putting intelligence into metals or into some objects. Okay, so that's the similarity. What is the difference? Now it's quite a big argument for many uh, uh, thoughts. Yeah, school of thoughts. So now let's just discuss, for the sake of discussion in our class, how do you think? I mean, it's just an opinion, not really, we're not saying that you're correct or not, but it's just an opinion. How do you think they are different? Mr. Haboroni?
Hello.
Mm.
I think the difference is with machine learning has the advantage that it can actually improve upon itself. So the more data you feed it, the better it becomes at making a decision. Like if you made a facial recognition thing and you give it more faces, it becomes better at seeing faces. So machine learning has the ability of improving upon itself, whereas artificial intelligence is the same as when it was made.
So you're saying artificial intelligence cannot improve in its own?
Yeah, that's in my opinion.
Okay, that's in your opinion. Yeah. But people will be mad at you. They will go to your room and punch you. That's not correct. But it's okay. Both of them, I mean, they have the ability to learn. Once you learn, you improve, isn't it? Yeah, that's why we're learning here. We go to school to learn. When we learn, we improve. So imagine when you graduate from BUST and you go back to your village and compare yourself to other people who didn't have the ability, the opportunity to come to BUST and learn. You know, you see the very big difference. Okay, but when you learn, you improve. Yeah. Okay. What else? I have to correct you there, Mr. Mupati, because okay. Why is it?
I think the difference between artificial intelligence and machine learning is that artificial intelligence is working on creating intelligent systems that can perform complex tasks, whereas machine learning is to create machines that can perform only specific tasks. Yeah, that's the difference.
Okay. So you think machine learning, I mean, artificial intelligence has more tasks that can be able to perform compared to machine learning. Machine learning tasks
Yes.
are only limited. Okay. Some people will say that. Okay. What else? Masa?
Yes, I think that since artificial intelligence was created to mimic the human brain, it has more chances in maximizing success rates because it can actually solve more complex issues than machine learning can.
Okay. Well, in terms of solving, I mean, yes, I mean, that's your opinion. That's correct. I want to add to it. In terms of solving, both of them can solve, okay, more or less. Yeah. There is just the ability. I mean, what people are arguing, okay, I'm just saying, although other people have different opinions. Yeah. What people are arguing is that when you say you want, oh, Moses, you want to raise your, okay, Moses, I will let you say it before I say mine.
Okay, I think that the main goal of AI is to create a smart computer system that can think similar to how a human being is able to solve complex problems. Whereas machine learning the goal is to help a machine learn by using past experiences. So like you said, one is subset of the other.
Okay. Yes. Yeah. That's correct. So, but I mean, that's correct. It's still other people will argue, but for the most part, when we say, okay, let's just, for the sake of discussion, say that artificial intelligence, as the definition is saying, that it is the ability to have like a human intelligence. Okay. So while machine learning, we say it can gathers information from data. So in that sense, okay, in terms of extracting data and gathering information, I think both of them have the same ability. You know? So that means that if you give them data, they will try to extract the information, okay, and make decisions somehow from that data, okay. For the most part, though, in machine learning, the machine learning presents data to a human. That's what other people will say. Presents the data to the human and let the human make the decisions. Okay, I gather all this information and now I analyze them, I compute them and give you this according to me as a machine learning system. This is the best solution for you. And the other solutions are like this. It's up to you to decide which one you would want to choose. Okay, some people would argue that this is what machine learning is doing. And you say, okay, then the human person will say, okay, I choose this solution. Although it is not the best solution, but somehow I see that in the future, for example, there will be more advantages to this kind of solution. Okay, so somehow in the decision-making process, the human person is there. Okay, so that's what they were saying in machine learning. But other people will also say, okay, yeah, but based on that particular instance of coming out with a solution, why not implement it immediately? You know, let the machine learning implement and make decision. Okay, now this is the solution. Okay, so that's kind of, you know, what machine learning is doing. Okay, let's just say it is also capable of making decision from the information that it gathered. Okay, that's what I prefer to define machine learning. But why is artificial intelligence different? Okay, so again, artificial intelligence can gather information, can extract information from data, and also can make decisions, yeah, with or without the human intervention. So again, we're saying that there is more to that for a human person, for a human brain, than just gathering information and making decisions. Okay, what is that? Well, for us as humans, we know what's that. Okay, then the question is, can we impart that other kind of intelligence, other kinds of intelligence into the machine to make it fully like a human person, you know, thinking? Okay, so that's what the argument of most people are. Okay, so in a sense, artificial intelligence is somehow the very big picture, and then machine learning is part of it, where machine learning is the one that processes the data and gathers the information and somehow make decisions. Okay, so in that case, I think let's agree to that artificial intelligence is the much bigger mother, and then machine learning is a subset of it. But then in this class, we will, because, you know, in both cases, artificial intelligence and machine learning gathers information from data. Then in that sense, you know, this is what this class is all about. We take information from data. And so in this class, we interchangeably use them. Okay, so I hope that makes sense to you. So for example, there are processes in machine learning. So we write a program to recognize a face, okay? But then we don't know what the program to write or to copy, how humans do it. Even if we have, it will be a very complicated program. So how do you write a program to recognize a face, for example? Okay, without machine learning, for example, how do you, without any prior knowledge of machine learning, how do you write a program to recognize a face? You have, how many programming classes you have? How many?
2.
You have C program, yeah? What else?
C++.
C++, object oriented, yeah, okay, 2, and then up to there, that's all, yeah?
Yeah.
Okay. And this is the third one, yeah, okay, so there was more, but anyway. So if you write a program to recognize a face, like write hard code programming, okay, how do you do it?
I think you need the variables you're comparing to.
Yeah.
So let's say it's my face, then I would measure distance between my eyes, width of my nose, of my mouth, the distance between, and then that'll be the variables you compare to. And then you have another set of variables for the current, and then it compares whoever's in front of the camera, and then it does that. And then it makes a decision based on that, the result. If they're almost similar, or if they're similar, then I guess. If not, no, it won't accept.
That's correct. And imagine how long is that program? Okay. But, well, for example, if it is just for one person, maybe we take, let's just say that you have a program, you already have the data that the location of, for example, the eyebrows are here in the location of the picture, another eyebrow is here, and then the nose and the mouth, okay, and then the eyes, okay. So let's just say like that. So we know the distances. Yeah, as Tepo was saying, we extract the distances, and this is the, the length, the ratio of the mouth, So do you know that some people have the eyes much closer to their mouth? Yeah, and some eyes are a little bit wider than others, the location. Yeah, so maybe, but the nose, of course, we know this because it's very clear. Some noses are different and the shape of the lips are different, but the eyes, we don't, some of them are closer and some of them are farther. Okay, and some eyebrows are like that, especially if the person is mad all the time. And some eyebrows are just flat. Yeah, so now, it's just like what Chepo is saying. So we have to compare this with another picture of a person, the location of all these. Yeah, the location of that, and compare the distances. So imagine if you have another third person, how do you compare? And then another one, somehow there's some sort of fine tuning. Yeah. So you fine tune that so that this picture in this one, you adjust some gain so that, this one will really recognize that this is that person. Yeah. And separate that person to the other person. Imagine how much fine tuning you will do if you have like billions of pictures to compare. Yeah. So the hard code, this is the power now of machine learning, of programming through machine learning. The hard coding program will be much more complicated, and probably most likely, or not just probably, but most likely won't be able to give out a confidence level in terms of classification that indeed this person is Chepo and not Moses, for example. Yeah. But the nice thing about machine learning is that from there is the learning process. It's able, you give it more, the more data you give it, the more information, the more valuable information, let's not use information, but the more valuable data or variables that it can use into the program in order to build the model much more accurately, and then come out with a much better decision or come out with a better classification. Okay, so that's why people, especially for much more complicated programs like facial recognition, people don't do hard code programming. That is not the way to go. Okay, it's very complicated and you won't get the desired results. Okay, so now facial recognition is considered to be a solved problem already. Okay, so if you can see, that's why we mentioned yesterday that you go to Facebook and somehow somebody Facebook will say, hey, you're somewhere, you want to tag yourself, like that. Yeah, hopefully it's it's a joyful occasion where you want to tag yourself, not some occasion that you don't want to people to see you, yeah, somewhere. Yeah, anyway, so in that cases, we agree that, you know, in much more complicated programs, we need machine learning. Machine learning is a better way of programming. Why is it better way of programming? So you say machine learning takes data, takes the data and produces a program. Okay, a program looks different from the handwritten programs. It is a totally different program. Yeah, it uses some basic principles of computation and just keep on, you know, modifying certain gains and all these other things and combining those principles together and somehow come out with an answer. So then the way it is being programmed is not the same as your programming by hand. Okay, it uses certain principles. For example, if decision tree, it uses the principle of that decision tree. So it comes out with a basic computational model. And so its answer will be based on that basic computational model. Okay. Or if it is Bayes rule, again, it is this equation, it is what it is using. And then based on that equation, come out with a solution. Okay. So there is a model, or neural network. There is a model that is being built where the data is being built upon, so that now you extract information from that model. Okay, we'll discuss it somehow. But what this slide is saying is that your program will be much different than a handwritten program. You use the model that is being used by that algorithm of that, you know, that particular algorithm that you want to use in this programming. For example, in the facial recognition program. Okay, so now, the good thing about it is that once you give it a data, an unforeseen data. So this is the keyword here, the unforeseen data. The data it doesn't know about. It will able to tell whether that person is similar to the other person where we build our information. Okay. Okay. So this is the most powerful thing about machine learning, that for something that is never seen before, it will be able to make decision. Okay. So most like maybe it can also be there in the handwritten program, but again, the complexity of the program and the accuracy of the results may be a very big problem. Okay, so now this is a classic problem of what makes number 2. Okay, so here we can say, well, these are handwritten numbers, and then somehow the pixels are arranged. Okay, similar to, these are the basic information also of facial recognition, you know, how the pixels are arranged. Yeah, so now the pixel arrays like this, somehow maybe this is number 2. Okay, these are the variations of what a human person will write number 2. Okay, depending on the country, depending on the culture, depending on many other aspects. Because for example, if you are Chinese, maybe, you know, you write number 2 somehow is related to how you write the characters. Yeah, so your hand is trained some way to write number 2. But if you are, for example, an American or an Arab, you know, an Arab also, they have a different way of their letters. Maybe somehow it will also influence the way they write numbers. But anyway, the numbers, number 2 is all the same for everyone. It is just, the number 2 is all the same. It's just the way people write. Okay, and so these kinds of variations of number 2, which one do we consider as number 2? So here, this looks like number 2. Maybe if you're sleeping and then you write number 2, or there's no light, you know, or you just imagine writing number 2. This 7 also looks like number 2. Yeah. So now, how do you discriminate which one is the true number 2 and which one is not the true number 2? Okay. So again, this is what character recognition. Yeah. Even in character recognition, this kind of method is used, because even the characters, you know, somehow they are written in a different form, or different font, or different writing even. Then this is how they are being recognized. Okay. So So some examples that are solved by learning algorithms or machine learning algorithms are, okay, recognizing patterns, okay, recognizing patterns or generating patterns or recognizing anomalies, and as well as prediction. So for those recognizing patterns, we say patterns in terms of face, yeah, facial expression. Okay, we are right now, we are part of my research is emotion studies. So we don't base, a lot of people are basing emotions from facial expression. Okay, a lot of people, maybe some people are good at hiding, but then probably this is not true all the time, because a lot of people are hiding smiling, even though you're sad. Yeah, smile even though you're lonely. Yeah, that's what people say. So smile and the world smiles with you, even if your heart is broken. Yeah. So anyway, so you'll have, those facial expression is what, what will be recognized from the camera, but it is not the real, it is not the real emotion of the person. So if you really want to see the emotion of the real person, what we are, a lot of people, and we are following some research that you are doing the brain signals. Okay, the brain signals is a center of also emotion. So if you want to study emotion, you just don't look at the facial expression, but also the brain signals. Okay, so recognizing patterns, the brain signals has certain patterns as well. So it still falls into these recognizing patterns. Certain brain signals of this particular pattern grouped together. This is the brain signal pattern of someone who is sad, and this is the brain signal pattern of someone who is happy, like that. Yeah. So those are still pattern recognition. So the same thing, handwritten and spoken words. Spoken, handwritten, this is what in the previous slide is. Spoken words, the same thing, the same as the emotion study that I mentioned. It's just signals. Now the emotion study, it is the brain signals. For us is EEG signals. Here in the spoken words, then it will be the sound signals, yeah, audio signals that you're going to process. So in this particular group of voice, signal, this is what A is, and this is what that person is saying. Okay, medical images, this is particularly used in many instances already. For example, recognizing whether a tumor is cancerous or not, it's been a very useful tool. Okay, so imagine, you just don't know it, but right now there's so many machine learning things that are helpful to us as humans, especially now. If you think, how are we winning in terms of cancer battles? Okay, maybe compared to 30 years ago, no, there are more people surviving cancer now than 30 years ago. So how do you attribute that? Probably because there are many things, yeah? There are many things that can attribute to that. Probably we are coming up with medicines that are much more effective, yeah? The other one also is that we are able now to diagnose, at the first instance of a cancerous cell, yeah? So, in cancer, it's more of early diagnosis. If you detect it earlier, then it is more manageable, okay? What are the other things? Yeah, probably it can help also in making the doctors making decision. Somehow doctors are also human; they can commit mistake. But with the confirmation of the machine learning analysis, it can help them make good decisions. Okay, so that's one. Now, those in the medical field, machine learning is really having a very big impact. So generating patterns, generating images. Well, how do you think people are doing in terms of animation? Okay, the previous animation, they were just drawing sequence of movement. Yeah, if you see those pages like this, and Disney, we are putting pages like that. I think you have seen this one, and then it moves. Yeah, as the pages goes, flipping through the pages, the picture moves. Okay, that's the principle of moving pictures. But there are other ways of generating that automatically. Well, in other cases, it's together with some simulation, platforms, and these graphical, platforms where you create images. You just draw them, and then now you control certain movement, and then you write equations. You don't draw them one by one anymore. Okay, it's either you write equations of motion, or you predict what will happen if this is the case of, you don't draw everything, but you make the calculation in order to predict what will happen in the next sequence, or you generate the principles of motion equations, and then the next the next sequence will be just generated using computation. Okay, those are generating patterns. Recognizing anomalies, well, in the credit card, once you have a credit card, they will tell you, hey, probably this is an anomalous transaction. Somehow there is some transaction in Seychelles. Are you in Seychelles? Yeah, normally anomalous transactions are in Seychelles. Where is Seychelles? Eastern Africa, right? You know where Seychelles is? Is it in Eastern Africa? I think it's in Eastern Africa. It's a small island next to Madagascar. I'm not sure, but I think that's my impression. Okay, anyway, so unusual patterns of sensor readings in nuclear power plant also, yeah, that's very good, Now it's very important, especially if there's some anomaly in the nuclear power plant, is very dangerous. And prediction of stock exchange, if you are into the stock exchange, investments. Okay, so web-based application, we don't need to go through each one of them, but we'll just highlight some of them. Spam filtering, what makes you think that, how people filter your email, so that most likely this email is a spam. Okay, there are keywords, for example, once the email has a Viagra word in it, for sure it is spam, unless you really ordered Viagra. So, but anyway, so if you ordered one, you have to go through your spam email, maybe it's there. Okay, but once you have that, it's nobody's laughing at my joke. Okay, anyway, so if you order that, it will be a spam. And also, what other words? You won $1 million, for example. No, okay, you won. How can you win $1 million when you don't even join any lottery? Yeah. So those most likely are very high probability of being a spam. Okay. Yeah, like this $1 million prize, like that, information retrieval. Okay. Anyway, so those are just some keywords that they will use in judging whether you have a spam email or not. Okay. Now, in this case here, the machine learning most likely, will be able to display your information or your data as they process it in a certain way, that you like. But somehow the human person also needs some kind of intervention in order to display or to visually display or to have a visual or graphical representation of the data, so that it will help in the person making certain judgment. So in this case, for example, PCA, a form of latent semantic analysis, or PCA, a form of PCA, principal component analysis, or something like similar to computations using SVD, singular value decomposition, or eigenvalues. Those are similar computations. It's just saying that the main components of certain data, they only display, for example, in the 2D case, they will display the first two major components of a data. Okay, so in this case here, these are the colors of the data. Is saying some, maybe let's just say, for example, these are a group of people. These are some ethnic, for example, ethnicity, of people. People of the purple ethnicity normally goes to this particular school, and go work somewhere. People with green ethnicity normally, a majority of them prefers to go to this school and go work like that, and then the blue ethnicity like that. But then from this picture, it's quite hard to judge what exactly is the information that we can predict here, because now they are somehow overlapping on each other. So in that way also, the human person needs to have, a better picture, the graphical representation of the data that was processed for the human person to be able to make a good decision or good analysis of the data that is presented by machine learning. So this is just one example of how machine learning cannot be very useful, although it processes the data and presented you the data. In this case, it looks like, the data is all over the place. But somehow, if you use a different kind of model, so in this case here, they use model or algorithm using principal component analysis, PCA. In this case, they use a deep learning neural network. So now we are saying here, this is a much better display of the data. So in this case, we are saying about some ethnicity of people. But anyway, so we say that here, they say it is more, it is the structure of the set of documents. This is some documents that are submitted in a government office. So documents on energy markets, these are the documents here. And then for economic indicators about accounts and earnings, government, like this. So these are the documents and how they are separated from each other and how they are related to each other as well. Okay, so we can say, okay, graphically, what can we say? Probably the green documents, account and earnings, are much more as a wider spread compared to all the other documents. So probably in that office, there's a lot of documents that are sent in the using these earning or accounting documents, and somehow these accounting documents is much related to the economic indicators document as well as government borrowings because they are close to each other. Okay, and probably not very much related to the interbank markets or European community monetary, like that. Yeah, so this particular display will give you some information and will help you interpret the data that is given. Okay, this is just some part of why, some example of how machine learning can process data, and why some tools are more useful than or more come out with better results that can be processed in terms of interpretation, that can be better interpreted accordingly than some other methods. So for example, in PCA, the result is not that not visually good. Maybe in PCA it looks in this direction. Yeah, that's why it has a side view probably. But for the neural network, it comes from this direction. Then it sees the wider perspective. Okay, I'm just guessing because it looks like this one is a side view and this one is the front view. Like, have you seen a starfish? Yeah, a starfish that's like this, or the starfish you look from here. But if you look from here, this is that starfish. You see the difference between the different documents. Okay. Anyway, so let's go from here. So in terms of machine learning statistics, okay, I'll leave it up to you to read through this one, because machine learning somehow can be very similar to statistical approaches. In fact, it is many people consider it statistical because the method of machine learning or artificial intelligence are just estimates, and the statistics is all about probability and estimates. So machine learning is not an exact science. We're not saying that the answers are exact. We only have certain percentage of accuracy. We don't compute like in basic mathematics, like you compute the length of one side of the triangle and the exact number. This is if the two sides are here, this is the length of the third side is like that. No. For machine learning, if the two sides are like this, then we will come out with an estimate that most likely the third side is like that. Yeah. So you can see in some examples, not all problems can be applicable to machine learning. Why would you use machine learning to compute the side of the length of the side of one side of a triangle when it's already there? You can still estimate it if you want, but maybe somehow, let's say for example that the triangle is not a real triangle, you know, and then machine learning will have to draw what are the lines that can fit like a triangle with the maximum area, for example, maybe. Then this is a machine learning problem. Okay, but if everything else is just ideal and mathematically, you know, can be computed with direct mathematics, then we just use that. Okay, so now we say then I'll just leave you to discuss, to read through this one. Okay, so now we say there's a spectrum of machine learning and task. This is the last one, and then afterwards we'll take a break for 5 minutes. Okay, so in statistics, comparing statistics and artificial intelligence or machine learning. So in the statistics, normally the dimension of data is less. Okay, and so when the data becomes very, very high, then we use artificial intelligence or machine learning. For example, like what kind of problems we are mentioning about, you know, facial recognition, the data is so much, but the other data can be like a self-driving car. Yeah, for sure, the data is so much. You know, looking at many, you know, scenarios as the car drives. You know, this is not solvable using statistics. So now you really have to go machine learning. How do you drive the car in a real world scenario? Okay, there's lots of noise in the data. Okay, statistics can have lots of noise in the data. For artificial intelligence, the noise is not sufficient to obscure the structure of the data if the process is right. Okay, so that means that for data, for statistics, you know, if there's lots of noise of the data, there can be lots of noise of the data, and the result can affect that. Okay, but for artificial intelligence, there is noise, but if you build the proper model, it will be able to know, you know, it can be able to disregard or to reject the noise and be able to come up with a good, you know, with a good information. Okay, there is not much for statistics. There's not much of structure in the data, and what structure it is, it can be represented by a fairly simple model. Okay, but in the machine learning or artificial intelligence, there's a huge amount of structure in the data. But the structure can be too complicated and you cannot have a simple model. Okay, so why is structure important in the data, especially for statistics? Because this structure can help them build a simple model. It can help them make their statistical analysis. But for a much more complicated structure in the data, then, you know, statistics won't be able to do it anymore. So we move to machine learning, but then this very complicated structure can still be modeled in machine learning, but the model is not anymore that simple. It becomes now a very complicated model, and you cannot just use a simple model to say the structure. Okay, so next, the main problem is distinguishing between true structure from noise. That's the main problem, okay, for statistics. So you have to know, that's why the noise you have to reject. You need to be able to find what is the true structure and be able to reject, to tell that this is the structure and that is the noise. That is important for statistics. Well, for artificial intelligence, the main problem is figuring out a way to represent the complicated structure that allows to be learned. Okay, so how is this different compared to distinguishing the true structure from noise? How are they different? It looks like they're similar. Okay, it looks like you have to distinguish the structure. You still have to know the structure in statistics, yes, so that you will determine which one is the noise and which one is the real information. Well, for machine learning, it's also the same thing. You figure out a way to represent the complicated structure. So in this case, what the difference here is that to figure out a way to represent the complicated structure, it means that you need to find a good algorithm, a good machine learning approach that will represent the complicated structure. but for statistics is limited to simple structures of the data. Okay, that's how they are different. But still, both of them, in terms of similarity, both of them are relying on the structure of the information from the data. Okay. So now let's take a break from here. Any questions? Do you have questions, or you're somehow, let's see, let's stop sharing so that I can see your faces. Do you have any, oh, somebody's, sorry for being late. Yours truly, TA. Oh, Miss Josejo, are you here? Josejo, come on, I want to introduce you to the class.
Yes, I'm here.
Okay, can you show your camera?
Okay. I'm having a bit of trouble.
Okay. Okay, anyway, you can just show your picture. Okay, at least you have two ladies now in the class. Yeah, Mr. Howney is really smiling. You're smiling from ear to ear.
I had a question.
You have a question? Yes. What's your question, Howney?
With the difference between statistics and AI, I was wondering that if AI has less noise that is insignificant when we process the data, how is it difficult to determine the difference between the algorithm structure and the noise with AI, unlike in stats?
Can you say that one more time? So it's about statistics and machine learning and AI. Okay. So what's the difference? So you're talking about noise. Okay. Tell me. Can you say that again?
The difference between statistics and AI. In AI, you said that the noise in AI is insignificant, so it won't distort the information when we process it. Unlike in statistics, where there's a lot of noise. And then the other difference was that because of that noise, in statistics, it's hard to differentiate the actual data from the noise. So how is that the same for AI if there's less noise?
Yes, I mean, there's not, well, it's not that there's less noise. So both of them have noise. Yeah. So the problem there is that in order to reject the noise, you need to have a structure in the data. Okay. What I'm saying, both of them have noise. In artificial intelligence, it's able to reject the data. I mean, sorry, to reject the noise more strongly because it can build a much more complicated structure. So now, if your model that is being built is a true representation of the data, for sure, you will know which one is the noise and which one is the real data, because you were able to model. That's the key word there. You were able to model the data in the, not maybe the exact structure, but a structure that is as close as possible to the real structure. We don't know what it is. Okay, it is about building a model. That is the keyword. Building that model that will truly, or not truly, but there will be as close as possible to the model of the real data. So now, because of that, it is able to reject, or it's able to discriminate the noise. You say, so that's why if you come out, just like a person, I am a very determined person. Okay, I know exactly what I want. So if the noise comes, no matter how big, it's just easy to, because I am true to my structure, so I can easily discriminate the noise. But then in the statistics, the problem with the statistics is that it cannot build a really, because of the way things are computed, it can also only build simple models. Okay, so for example, let's just say it can linearize only certain models, represent everything to be aligned, for example. And then you can see if it's not a well representation, it's not a good representation of the real structure of the data, then it's very hard to discriminate noise. That's all. There's not. It's all about, both of them will always have noise, but the ability to, the keyword is discriminate, to be able to say that this is noise and this is not noise. Okay, but it's a good question. I thought you were asking about Miss Camela, but the question is about noise. Yeah. Okay. Very good. Okay. Miss Oseo, you still didn't show.
Yes, my PC is having trouble allowing Zoom to access the camera.
Okay. Okay. Anyway, but welcome to the class. Okay, let's have 5 minutes break. Or what is it a 5 minutes break or 10 minutes break? Okay.
10 minutes.
Okay, let's do 10 minutes. Who's that? Okay, let's do 10 minutes. And we'll be back at 12:20. Okay.